Evaluate the limit as t approaches 0 of 2 to the t minus 1 multiplied by cosine 1 over t. Now notice here, if we just plugged in 0 for t, we would get 1 over 0, which would be undefined, so we can't do that. So what we have to do is use the squeeze theorem, especially for this trig ratio here. So what we have to do is recognize that the cosine of any angle, no matter what it is inside, has to be between -1 and 1. That's true for all cosine, all sine. Any value that you input, you'll always get a value in between -1 and 1. -1 is kind of the minimum, 1 is the maximum you can have. And so from this inequality, we can figure out the limit of cosine 1 over t. And so how we're going to do this is first let's multiply all parts of the inequality by 2 to the t minus 1. So I did it here, I did it here, and I did it here. And now the reason we did that is so this middle part is the limit we're trying to find right here. So now what we do is we take the limit of each part of the inequality. So you can see I just add the limit sign as t approaches 0. And of course the 1 kind of just disappears here. And so now for the ones on the outside, to evaluate these limits, we can just plug in 0 for t. There's no 1 over zeros or anything that's going to pop up. So 2 to the 0 minus 1, that's 1 minus 1, so that's 0. So this whole part is 0 on the left. Similarly, on the right, we have 2 to the 0 minus 1 again. So it's 0 on the right. And so because the limit in between has to be greater than or equal to 0, but also less than or equal to 0, that means the only value, by the squeeze theorem, the only value that's possible is that this limit must be equal to 0. And so our final answer is the limit is equal to 0.